In this section of 7.1, we're going to use the law of sines to determine if no triangle, one triangle, or two triangles can be formed from this diagram. And if two solutions exist, solve them both completely. So this is, let's assume this does make a triangle and that these sides do in fact meet up. So we can just label that C. So law of sines tells us that sine of C is to C as sine of B is to B and sine of A is to A. So what do we already have? This is a side-side angle. So here's my notes on side-side angle. So I start by using that law of sines to find a second angle. So I have to be, I can't find angle B because I don't have side B. So I won't be able to, if I try to use that ratio, I'll have two variables. So I'm going to try to find angle C. I already have A. So I'll use the A's to give me the C. So I'm going to rewrite this as sine of C is to C as sine of A is to A, which gives me sine of C is to 5.9 times 10 to the 13th equal to sine of A, which is 51, is to 6.8 times 10 to the 13th. Okay, I'm just going to move that up to give myself a little space to do my cross multiplication. So I get, 6.8 times 10 to the 13th. All of that times sine of sine of C equals 5.9 times 10 to the 13th times sine of 51. And then solving for C, solve for sine first, and I get 5.9 times 10 to the 13th times sine of 51 all over 6.8 times 10 to the 13th. And then I got to put that in my calculator to see if this is going to, so I need to see which case we're in here. No solution, one solution, or possibly two solutions. So I'm going to stick that into my calculator. And I get so I'm going to actually do parentheses on my numerator and denominator to make sure my order of operations follows that rule. 5.9 times 10 to the 13th times sine of 51. Close that, close my numerator, and then divide by, open parenthesis for the denominator, and do 6.8 times 10 to the 13th. And then close the parenthesis for the numerator. And that gives me 0.674. So to find C, I take sine inverse of that, which is approximately 42.4 degrees. I just want to see what to round to. All right, doesn't mention. Okay, so that tells me C is 42.4. I'm going to make a little, let's see here. So I have A is 51, C is 42.4. So I'm in case 3. Whoops. So I could have one or two solutions. So the second, if there is a second solution, so I'll call this theta 1, or C1, I guess. This would be choice 1. If there is a second solution, that's this line, then the other solution would be 180 degrees minus that. So if I try to get that, I get 137.6. So to find out if that is a possibility, read here the possible solution. If that second solution with the angle we already have is more than 180 degrees, then that's too big and it's not going to work. So we already have 51 degrees. So add that to the 137, 51 degrees plus 137.6, and I get 188.6, which is too big. So that tells me that this is not a possible solution after all, and I actually only have one possible solution with the C equal to 42.4. All right, so now to make my little triangle solution box, I'll just dig a little bigger here. So I have side A, side B, side C, angle A, angle B equals C. I have angle A is 51, angle C is 42.4, angle B is to be determined. Angle A is, side A is 6.8 times 10 to the 13th kilometers. I think I should have made my little triangle bigger, my little box bigger. And B is unknown. And side C is 5.9 times 10 to the 13th kilometers. Okay, so I still need to find angle B and side B. So I can't use a law of sines for that since I would have a ratio with two variables. So to get that third angle, I'm going to use that step 4, use the triangle sum. So I have 180 degrees minus A and minus C will give me angle B, which gives me 86.6 degrees. So B is 86, and then I can use step 5, use the law of sines again to find that last side. So I'm gonna kind of running out of space here. So I'm gonna use a law of sines again. This time I need to have the B ratios in there. So I have sine of B is to side B equals, and it doesn't matter if I use A or C since I have them both. I'm just going to move that over here so I have a little more space to do my cross multiplication. So I get sine of B. What was B? B was 86, so that's sine of 86.6. And I'm looking for B. And sine of A is 51. And side A is 6.8 times 10 to the 13th kilometers. So I need to solve for B. So I get B times the sine of 51 equals 6.8 times 10 to the 13th times sine of 86.6. That's my cross multiplication. And then to get B by itself, I divide both sides by sine of 51. So I get 6.8 times 10 to the 13th times sine of 86.6 all over sine of 51. And that is a good time to grab my calculator. And I get, whoops, where'd it go? I'm going to use my parenthesis on my numerator. 6.8 times 10 to the 13th power times sine of 86.6. Close the numerator and then divide by, and I'm using the numerator for the parenthesis for the denominator, and I do sine of 51. That doesn't seem right, does it? Well, actually, I guess it is because of that 10 to the 13th power. So that 10 to the 13th power really means 6.8 with 12 zeros after it. So that's the same thing here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we move that decimal over 13 spaces, we actually get 8.7 times 10 to the 13th. So that 13 tells me I can move my decimal over. Okay, so I think that's our final answer. Put my 8.7, I'm going to make this table a little bigger. Okay, that's a little better. I can see everything on the table now. So A was the 51 degrees. C was the one we found, the 42.4. Let's see. Looks like I lost B. So B, I think I erased it, was 180 minus A and minus C. So that's B equals 180 minus A minus C. So that is, which gave me 86.6. So that's one thing, that's another thing, and that's one thing. And side A, 6.8 times 10 to the 13th. Side B, 8.7 times 10 to the 13th. And side C, 5.9 times 10 to the 13th. And kilometers on all of these units, degrees on all the angles, and I'm done.